Hello friends, welcome to first lecture of Fourier series for MSc and BSc students mathematical physics. So before we start, please subscribe the channel if you are new to my channel and share with your friends. If you like the video, then hit the thumbs up button. Also hit the bell icon so that you get notified when new video will be uploaded. And you may check the playlist in my channel because I have made videos on different topics, classical mechanics and plasma physics, mathematical physics, other topics of mathematical physics. Okay, so now let's start our topic today, that is Fourier series. And if you want to follow me on Instagram, you can follow, and this is my Insta ID, Lec-01. 123. This is my Insta ID. So now our topic of discussion is periodic function. First we're going to discuss about periodic function. Before we discuss about Fourier series, let me explain what is periodic function. So now you see, a function is said to be periodic. So a function is said to be periodic if it repeats its value at equal intervals. Okay, that means suppose we have a function f of x, this function of x such that f of x is equal to f of x plus t, f of x plus 2t, and so on. So here you can see its value is repeating after an interval of capital T. So here it is a periodic function and its period is capital T. Right, capital T is the period of this function. So now you see, for example, let me take the example of sine function. If you see the graph of the sine function, then sine 0 degree at 0, the value of sine function is 0. So let me draw it properly. So these are the angles, right? So now you see, at pi by 2 its value is plus 1, at pi again it is 0, then again 3 pi by 2, at 3 pi by 2 this is minus 1, and at 5 by 2 this is plus 1, and here at twice pi it is 0. So at pi it is 0, right? And at pi by 2 it is plus 1, right? So here you see, if you see the repetition, this is plus 1, this is plus 1, and interval from pi by 2, between pi by 2 and 5 pi by 2, this is 5 pi by 2 minus pi by 2. So what will be the interval? So here 2 is the LCM, 5 pi by 2 minus pi, 5 pi minus pi, that's going to be 4 pi. So here it will be twice pi. So here twice pi is the interval here. So here we can say that sine function, sine x, it is a function which is periodic and its period is twice pi, right? So hope you have understood this. Now let's move on to the next slide. So before we go to the next slide, let me we can write this sine function as sine x plus pi, and sine x plus 2 pi, and so on. Okay, at all those points this function gonna have the same value, right? Now let's move on to next slide. So now what is Fourier series? So here you see a series of sine and cosines of an angle and its multiples, right? So of the form, this is of the form, this form of series is called Fourier series, right? So hope you have understood this, right? So this is called Fourier series, right? So I have written this as a sum of here you can see, I will explain it later. Let me write first. Okay, it's called Fourier series, and here a naught, a1, a2, dot dot dot, b1, b2, b3, these are all constants called Fourier coefficients, right, or Fourier constants. So here you can see this sum of this part, a1 cos x, a2 cos 2, a3 cos 3, an cos nx, this can be written in this way using summation from n to sum from n to infinity, an cos nx, right? And this part here you can see can be written in this way. So hope you know these things. These are very simple things, right? So now this is our Fourier series. Okay, this is called Fourier series. Now we have some few conditions. Now let us discuss about Dirichelet condition for Fourier series. Right. Now you see. So if we have a function f of x for interval minus pi to plus pi, right, open interval, so then is single valued. Number 2 is bounded and has at most finite number of maximum and minima, has only finite number of discontinuous, and is here you see f of x plus twice pi and f of x, these two are equal for values of x outside this interval, closed interval minus pi to plus pi. Then this series at this point a naught by 2 summation from n to p an cos nx, then similarly sum of the series from 1 to p bn sin nx, convert to f of x as p tends to infinity. The values of p tends to infinity at values of x for which f of x is continuous, and it converts to this f of 0 plus half of f of 0 f of x plus 0 plus f of x minus 0 at the point of discontinuity, right? So let me explain it. Okay, so here these are the conditions to be satisfied for the existence of Fourier series. So here single valued function, that means suppose this is the domain of one function and its range of this function, then for one point there must be one image, at only one image in its range. Okay, that will be single valued function. Okay, suppose this point is here you see it has two images, this one and this one, then this is not going to be single value. So we have understood this. And this here you see it should be bounded. That means if you consider the curve of sine function, so if you consider the graph of sine function, you can see that the values of this sine function it varies from -1 to +1, right? You will get the graph of this kind, and it is bounded within -1 to +1, right? So this kind of function is called bounded, right? So here you see, let me clean these things, and has at most finite number of maximum and minimum within this range. That means suppose this is the graph, let me draw it again. So here is the sine graph, right? So this is 0, this is pi by 2, and this is pi, and then this is 3 pi by 2, then this is 2 pi, right? So here you see, let me take an interval. Here you can see from 0 to pi, or 0 to 2 pi suppose. Okay, so within this interval you can see you have a finite number of maximum and finite number of minimum. Okay, so that's what this third point means, and has only finite number of discontinuous. Okay, so in sine function there is no discontinuity, so if there is a discontinuity then it must be finite number, so within this range. So here you see, and one more important thing is here, as you can see, this series converges to f of x when p tends to infinity at the values of x for which f of x is continuous. Suppose f of x is continuous at x naught, x is equal to x naught, then this series will converges to f of x naught, right? And at the point of discontinuity, it converges to this half of f of x plus 0 plus f of x minus 0, right? So now let me go to the next slide. So here you can see some let me write some useful integrals. These are very useful integrals. This is equal to 0 and this is also equal to 0. Both of them are equal to 0, right? This one as well this one. Okay, so similarly these two results, this one and this one, both are equal to pi. So this is also equal to pi, this is also equal to pi. Similarly these two integrals also, this one and this one, both the integrals equal to 0. So similarly we have got this result also 0, right? So these are very useful integrals. So now let me show you how to find Fourier coefficients, that means those constants, a0, a1, a2, a3, b1, b2, b3, those are how to determine how to find their values. Let me show you in the next slide. Here, determination of the Fourier coefficients. So now you see, suppose we have a function f of x which can be expressed as Fourier series in this form, right? So this is the expansion, Fourier series, right? So here you see, this is suppose equation number 1. How to find that a0, sorry. So in order to find this, let us integrate the equation number 1, both sides of the equation number 1, from x is equal to 0 to x is equal to 2 pi, right? So if you integrate that, then what will happen? So integration from 0 to 2 pi f of x dx, then a0 by 2 integration 0 to 2 pi dx, and similarly other terms also integrated from 0 to pi. So let me write all the terms. Okay, so right, and so on. Now you see, here only one term will be left out, that is the first term, right? Remaining will be 0 because we have already got a few useful integrals. So here integration of dx is x, right? 0 to 2 pi, remaining terms will be 0, right? So why? Because 0 to 2 pi sin n pi dx, and also 0 to 2 pi cos n pi dx, n may be 1 2 3 4 anything, okay, dx cos n pi dx, both the integrals are equal to 0, right? That is why remaining parts will be 0. Here we don't have any cos and sine, so this part will be left out only, right? So we have got this is equal to this one. So let me write on the other slide. So what we have got, let me go to this slide. So finally we have got this result. So now you can see, putting the limits, what we have done here. Actually we had got here a0 to x 0 to 2 pi, right? X 0 to 2 pi. So that's why if you put 2 pi you will get 2 pi, then if you put 0 here, minus 0, so 2 pi minus 0. So hope you have understood this. So now you see, okay, so now it's become a pi because here these two will be cancelled, right? So this is our final result. A0 will be equal to 1 by pi integration 0 to 2 pi f of x dx, right? So this is the value of A0. Now let me show you how to find the an. So here what we have to do, we have to integrate equation number 1 into cos nx, right? That means we have to multiply this first equation. We should multiply this first equation number 1, by cos nx. Okay, both sides of this equation are multiplied by cos nx, right? Multiplied by cos nx. Then it is integrated from 0 to 2 pi, right? From 0 to 2 pi. So here you can see we have got this integration which is equal to after multiplication of cos nx and integrating this, we have got this. So here what we can do, you see, these terms, cos nx dx is 0, cos x cos nx dx, that's going to be also 0, because cos nx cos mx dx and sin nx cos mx dx both are equal to 0. So similarly, only one term will be left out, that is this one, right? Cos nx, that will be an integration 0 to 2 pi cos square nx dx, that's what will be equal to this term, right? So that's what we will get from this term. Then our remaining terms will be 0. So hope you have understood this. Now let me go to the next slide. So here we have got cos square nx dx, and if you integrate this, not needed. So there is a I have already given some useful integrals. From there, this is equal to pi, right? So let me show you that. Here it is. So integration from 0 to pi cos square nx dx is pi, right? So that is what that's the result that we have used here. So this is the important integral that we have used here, right? So, and using that, we have got a n pi is equal to this. So a n is equal to 1 by pi integration 0 to 2 pi of f of x cos nx dx, right? Similarly, we can find bn as well. So let me go to the next slide, then I will show you. So to determine bn, again integrate equation number 1 into sin nx. So in the last step we had multiplied cos nx with equation 1. Now we have multiplied equation number 1 by sin nx, and from integrating it from after multiplication sin nx with this equation number 1, we have integrated this equation from x is equal to 0 to x is equal to 2 pi, and doing so, what we have got this result. So let me write here what we have got this, right? Okay. Okay, so this is the result that we have got integrating the last equation number 1. Before we integrated, we have multiplied sin nx, then we have integrated from x is equal to 0 to 2 pi, and doing so we have got this series, right? So now here you can see that only one term will be left out, sin nx, sin square nx. Remaining terms will be 0, remaining results will be 0. If you see the useful identities that I have given, useful integrals that I have given, so since 0 to 2 pi sin nx dx is 0, this is equal to 0. Okay, 0 to 2 pi sin nx dx is 0, and 0 to 2 pi sin nx cos mx dx is also 0. 0 to 2 pi sin mx is also 0. So that means other than this term, all the not this one, other than this term, right, all the remaining terms will be 0. Let me go to the next slide. Before going there, here you can see these terms. This term will give you bn 0 to 2 pi integration sin square nx, right? Sin square nx dx, that's what we have got, right? Let me write here the last result. What we have got this, right? Remaining terms, remaining integrals become 0. So here you see why the remaining terms are 0. I have already mentioned the reason in the previous slide, that according to those useful integrals that I have given, using those we have got this remaining integrals become 0, and only this term left out. And here you can see from here we will get this result, because integration 0 to 2 pi sin square nx dx, that is pi, right? We have used that result here, and so bn will be 1 by pi integration 0 to 2 pi f of x sin nx dx, right? This is the result, this is the coefficient bn. So those values of a naught, a n, bn in equation number 1 putting those values we will get the required series, that is the Fourier series, right? So now let us solve a question. So this is the given question, right? Let me write the given question first. Okay, we have to find a Fourier expression of f of x, then we have to deduce this relation, right? So first let me write the solution. This is the given function, right? So now let this function be the Fourier series of this function is this, suppose. So this is the Fourier series, right? This is suppose equation number 1. Now how to find a naught? So we have already got that a naught is equal to 1 by pi 0 to twice pi. So 0 to, when we say 0 to twice pi, then the interval is 0 to 0 plus twice pi. You can assume that. Now here the interval is minus pi to plus pi. In this case you can replace this 0. You can replace this 0 by minus pi. So if you do so, then what you will get, minus pi plus twice pi, that's gonna be equal to plus pi, right? So we're gonna integrate minus pi to plus pi. Then f of x, here f of x dx. So then f of x dx is, you know, half, sorry, not half, here integration, let me write here, integration 1 by pi 0 to, not 0, minus pi to plus pi, and f of x is x plus x square dx. That is what we have got. Now integrate and put the limits, then you will get the value of a naught, right? So now let me show you. And integrating this, what we have got, this one. So integration of x is x square plus 2, and integration of x square is x cubed by 3, right? Integration of x is x square by 2, and that of x square is x cubed by 3, right? So from minus pi to plus pi, and if you put those upper limits and lower limits, then you're gonna get this value, right? And first two terms will be cancelled, right? These two terms gone, right? Then what we have got, a naught is equal to half 2 pi cube by 3. So here pi cube cancels pi cancels pi cube to give pi square. So this is the result we have got. This is what a naught. So we have got a naught, right? So now how to find an? Again 1 by pi minus pi to plus pi f of x cos nx dx, right? This is how we used to get we used to find n, right? So if you remember, so now here let me put the value of let me put the function f of x, that is x plus x square here. So now you can see, consider this one as u, this one as b. If you apply the product rule, then what you will get, just wait. So I have completed the integration. Let me explain how I have done. So here you see, I have taken the integral part only, ignoring the limits first. So then what we have done here, we have applied the product rule u into v, and this is the u integration of v, then integration derivative of u integration v whole dx, right? So again integration of cos nx, that's going to be sin nx by n. Hope you know these things. And derivative of x plus x square, that is 1 plus twice x, you know these things, right? So integration 1 plus twice x can be written as twice x plus 1, and integration of sin nx, sorry, cos nx, that's going to be sin nx by n, right? And then again here we have to apply that u into v rule, integration u into v, that is equal to u integration v minus derivative of u integration v. So we're going to use that rule here again, and doing so we have got this result. So n is constant taken out here, and this is the first function which is taken out, then integration of the second function sin nx, right? And then minus right? Minus, because of this minus plus, right? So hope you have understood, because according to this formula we should get a minus sign here between these two terms, right? So if you have already a minus here, then this minus will be plus, right? If you have minus here. So I hope you can understand this, being the student of BSc. So here you see, and derivative of this twice x plus 1, that will be only 2, and that is sine nx dx, and 2 is taken out here, n, and here you see, if you integrate this, you will get minus cos nx by n, right? Again, if you integrate this cos nx, this minus plus, it becomes minus, right? Again, if you integrate this, then you will get minus sine nx by 1 more n, that will be n square, and n square into this n, that becomes n cube, right? So hope you have understood this. Now you see, let me use this result here, right? So here we have limits from minus pi to plus pi. If you put those, remember one thing, sine n pi is 0. If you put here pi, that's going to be 0. It doesn't matter if you put minus pi or plus pi, that's going to be 0. These two terms going to be 0, right? Only this term left out, right? And let me go to the next slide, then I'm going to show you. So here is the next part. So this is the last result we have got. These two terms, sine nx, sine n pi is 0, that's why these terms are going to be 0 on putting those values of x is equal to pi or x is equal to minus pi. So only this term left out. If you put plus pi, you will get this result. If you put minus pi, then you're going to get these two results. And subtracting these two, what we have got, we have taken this is common, cos n pi is common here by n, and then within bracket we have got 2 pi plus 1, 2 pi minus 1, plus 1 minus 1 gone, we have got 4 pi, right? And cos n pi is 1 to the power minus n, minus 1 to the power n, right? So this is the value of an, right? This is the value of an. So we have got an. So now let me find bn, right? So here we're going to find vn like this way. So f of x, this time we need to multiply sine nx, right? Okay. So here again we're going to apply the u into v rule to integrate this, right? First function integration of the second function minus integration derivative of the first function, derivative of x and x square is twice x plus 1, then again integration of the second function, this is sine nx dx, then whole dx, right? So again here you see, integration of sine nx is cos nx by n, and there should be a minus sign, right? So I hope you know these things. Then minus integration twice x plus 1, if you integrate sine nx, that's going to be minus cos nx by n. So this sign becomes now plus because of minus, because of this, because integration of sine nx minus cos nx by n. So this minus it becomes plus, right? Hope you have understood this. Now here you see, again what we're going to do here, again we're going to apply the same rule, product rule, this rule, integration of u into v dx, that's going to be u integration v dx minus integration derivative of u integration v dx whole dx, right? We applied this rule here, and doing so we have got this result, right? So hope you have understood this. Just let me clean these things, right? So now if you simplify this, what you're gonna get, integration of cos nx dx, again it's gonna be this sine nx by n, this and this, and this will become n square, right? So that is what we have got. And if you integrate cos nx, you will get minus, sine nx, sine nx by n, this and this and that will be n square. Then again if you integrate this sine nx, then you will get minus cos nx by n. Then this n, previously we have got n square, then n into n square, that's going to be n cube, right? And this minus, so this minus plus, right? So hope you have understood this. So let me clean these things. So now finally we have got this result. So Bn is equal to this. So what we have done here, we have used this result here, right? Then we have got this Bn, and let me go to the next slide. So Bn is equal to, we have got this result. Now here see one more thing. This will be 0 because sin n pi is 0, right? So now we have these two terms only, right? So let me simplify. So putting the upper limit, we have got this result, and putting the lower limit, we have got this result. Then in the next term also, here also, if you put the upper limits and lower limits, you will get this, right? So first put pi here and you will get this one. If you put minus pi, then also you will get this, right? And these two cancels, so we have got this result. So cos n pi by n is taken common, so here these two cancels, so minus 2 pi, and right, this is Bn. Here you see minus pi, we have got minus 2 pi. So and here we have 1 by pi. Here you can see we have 1 by pi, so that pi cancels this pi, and then we have cos n pi by n. This cos n pi is nothing but minus 1 to the power n, and this is minus 2 by n, right? This is minus 2 by n. This is the value of Bn, right? So we have got Bn, and we have got an also. If you go to previous slide, this is an, this is the value of n, and you have got a naught also. This is the a naught, right? And putting all these value in this equation number 1, so then what we will get, if you put the values of a naught, a and bn in equation number 1, then you will get this, right? So what was the equation number 1? Let me write here. Equation number 1 was this f of x, which is equal to x square, x plus x square, right, is equal to pi square by 3 plus actually what we had here, equation number 1 we had here a naught, and we have got the value of a naught is equal to this, then plus summation n is equal to 1 to infinity. We had here a n cos nx, right? This value of a n is now this one, right? Similarly, plus n is equal to 0 to infinity, we had here bn and sin nx, right? Sin nx. Now value of bn is minus twice 2 by n into 1 to the power minus n, right? So using those values, we have got this result, and f of x is equal to this, so you can replace this f of x by x plus x squared. So that's why we have got this equation number 2. And if you put x is equal to pi, then what you will get, if you put x is equal to pi, so this x will be replaced by pi, and this x will be also replaced by pi, and sin n pi, it will be 0, this term will be 0, and so we have got this result, right? So now you see here cos n pi is nothing but minus 1 to the power n, and there is again one more minus 1 to the power n, so product of these two will be plus 1 definitely, right? So here the summation is from 1 to infinity. If you put 1 to infinity in n, then you will get 1 by 1 square, that is 1, 1 by 2 square, 1 by 3 square. Instead of 1 by n square, we can expand this way, right? So this is equation number 3. right? Similarly, if you put minus pi, this was equation number 3, right? This is equation number 3. I have written the equation number 3 again here. And if you put x is equal to minus pi, so if you put here minus pi, here, if you put minus pi here, then you're gonna get this result. So hope you know this result. So hope you have understood these things, how we have got this. So you will put x is equal to minus pi in this equation here. This minus pi plus minus pi square. Then here if you put n into minus pi, then it will be minus sine n pi. Sine n pi is nothing but 0, right? So we have got this result. That's why we have got here 0. So then cos n pi is this, right? And product of these two will be definitely plus 1. And then if you expand this sum, then you will get this, right? Now adding these 3 and equation number 4 here, if you add these two, then plus pi minus pi will be cancelled. Then pi square, that's going to be 2 pi square. And if you add this pi square by 3, we have got 2 pi square by 3. And if you add this term here, you can see these terms and these terms. These two terms are same, right? So we can write 2 into 4 within bracket 1 plus 1 by 2 square, 1 by 3 square, plus dot dot dot, so on, right? So if you simplify this, let me go to the next slide. If you simplify this, what you will get. So this is the last result we have got, and I have written here, and these two cancels, right? And again 3 is taken common, then this 4 is brought to this side, then 2 cancels 4 to gives 2, then 3 to the 6. So this is the result that we needed. We need to deduce, right? So hope you have understood this. This is what we have got. This is the required result. Here you can see in the question. If you see the question, let me go to this, deduce this, right? So at the final slide, here you can see we have got this result. So hope you have understood this. So in the next video, we're going to solve more problem based on this concept, right? So stay connected. See you in the next video, and thank you for watching. And share this video with your friends and hit the like button. Inspire me to create new contents for you. And if you are new to my channel, please subscribe the channel. So thank you for watching. See you in the next video. Bye.